Hello friends, myself R.D. Mahajan presenting my video on Engineering Mathematics 2 second unit differential equation revision part 1. In this video I will discuss 5 to 6 problems from the previous question paper. Therefore if you prepare it, it's very easy for you to attempt any type of question in the exam. Example number 1, solve x square minus y square into dx is equal to 2xy into dy. Try to convert in the form of mdx plus ndy equal to 0. By transferring this term to left hand side, we get x square minus y square into dx minus 2xy dy equal to 0. Then comparing it with general form of any differential equation, mdx plus ndy equal to 0. Therefore, we get m as a coefficient of dx. Here that coefficient is x square minus y square, and n is the coefficient of dy, that is minus 2xy. After getting it, differentiate this m partially with respect to y, keeping x constant. Therefore, derivative of this term is minus 2y. Differentiating n with respect to x, keeping y constant, derivative is minus 2y, constant term outside, and derivative of x is 1. And then as this condition dou m by dou y is equals to dou n by dou x, equation is exact differential equation. Always we check first for exact differential equation. If it is not exact, then we go for the remaining techniques. Here condition is satisfied and therefore it is an exact differential equation. And as it is exact, next step we have to obtain these two steps. In first step, integration of m with respect to x square minus y square, and its integration with respect to x. Integrating each term with respect to x, integration of x square is x cube by 3 minus y square constant, integration of dx is x. We call this as equation 1. Then next, integration of terms in n free from x, that we have to integrate with respect to y. Then we check, is there any term which is free from x? No term is there which is free from x, and therefore its integration with respect to y is 0, equation 2. Then solution is sum of these two. Solution is 1 plus 2, and we have to equate it to c. Therefore equation 1 is x cube by 3 minus xy square. Second equation is 0 and is equal to c is the required answer. Generally this type of problem is asked for 4 marks. Then I will explain the scheme of marking. If we try to obtain this dou m by dou y and dou n by dou x, and showing that, you will get 1 mark. Then integration of m with respect to x, another 1 mark. Integration of terms in n with respect to y which are free from x, 1 mark. And the last 1 mark for this last step. Total 4 marks. This is the tentative scheme of marking. It may vary by 1 or 2%. Therefore, always go step by step. Perform first step, then next, and then next. Then only you will get that complete 4 marks. Second example, solve y plus log x into dx and minus x dy equals to 0. It is in the form of m dx plus n dy equals to 0. Quickly we check whether it is exact or not. M is the coefficient of dx, it is y plus log x. Its derivative with respect to y is 1 and n is minus x, its derivative with respect to x is minus 1. These two are not equal, means it is not exact. And as it is not exact, you can check it orally also, as I have performed orally. Then we think whether it is linear in y or linear in x. Only one term of y whose degree is 1 means it is linear in y. We have to rewrite in the form of dy by dx plus py equals to q, general form of linear differential equation in y. Therefore, rewriting it, transferring this to other side, we get x dy is equal to y plus log x into dx. Then dividing by dx, we get x dy by dx is equal to y plus log x. Then transferring the term of y on left hand side and dividing by x, we get next step dy by dx minus y divided by x and is equal to log x by x. We call this equation 1. Compare this with this. Dependent variable is a y, independent variable is x. Degree of y is 1, degree of differential coefficient is 1 and not multiplied together, and therefore it is linear in y. And then compare and get the value of p and q. P is the coefficient of y, here it is minus 1 by x. Q term on the right hand side, log x by x. These two are either function of x or constant. Here both are functions of x. Then next step, we have to obtain integrating factor. For this form, integrating factor is e raised to integration of p with respect to x, integration of p minus 1 by x dx. It is e raised to minus integration of 1 by x is log x. Rewriting it by using the laws of logarithm, this I can rewrite as e raised to log x raised to minus 1 raised to n. E and log get cancelled, therefore we get that integrating factor as x raised to minus 1, nothing but 1 by x. Therefore, showing that it is linear, you will get 1 mark, and 1 mark for this obtaining integrating factor, and then applying the procedure to find the solution of linear differential equation. Then solution is given by dependent variable into integrating factor is equals to constant plus integration of q into if. Here dependent variable is y, integrating factor we are getting as 1 by x, constant term a plus integration of q term is log x by x into 1 by x and dx. And then you can integrate it by integration by parts or by substitution. Here I am using substitution technique. Substitute log x as new variable t. Therefore, x is equals to e raised to t, 1 by x as e raised to minus t. A reciprocal of this as 1 by e raised to t means e raised to minus t. And differentiating this with respect to x, we get 1 by x dx is equals to dt. Using all this information here, we get that step as y into 1 by x is equals to a plus integration of log x is t, 1 by x is e raised to minus t, and this 1 by x dx is dt. And then integrating it by parts, first term t algebraic, second e raised to minus t. First term integration of second with respect to t, then minus derivative of first with respect to t 1. Its next integration is e raised to minus t upon minus, and this minus it become plus, and next derivative is 0. We stop here. From this term I can take e raised to t common, e raised to minus t common, with minus sign also. Remaining terms are t plus 1. And then once again substituting the value of t, we get that solution as y by x is equal to a minus e raised to minus t, t is log x, 1 plus log x as answer. Remaining marks for this step, you will get 1 mark and 1 mark for the final answer. Total 4 marks. This is the scheme of marking. Generally, not exactly, it may vary. Third example, solve differential equation cos square x into dy by dx plus y is equal to tan x. If you observe the terms carefully, here y is dependent variable, x is independent, degree of y is 1, and degree of differential coefficient of y is also 1 and not multiplied together, means it is a linear in y. Only way to make the coefficient as 1, dividing by cos square x, we get dy by dx, 1 by cos square means secant square x into y is equal to secant square x into tan x. Equation number 1. It is linear in y. Linear means satisfies the definition. What is the definition? Dependent variable and its differential coefficient both must be in degree 1 and not multiplied together. And then comparing it with general form, dy by dx plus py equals to q. Y, coefficient of y is p, here that p is secant square x, and q right hand side term, it is secant square x into tan x. Integrating factor, it is e raised to integration of p with respect to x, e raised to integration of secant square x and its integration with respect to x. Integration of secant square is tan x, standard result. Therefore, it becomes e raised to tan x. And then solution is given by, for linear differential equation, solution is dependent variable into integrating factor constant plus integration of q into if. Always write down this step as a supporting statement while obtaining the solution. Here the dependent variable is y. In the integrating factor we are getting as e raised to tan of x constant plus integration of q. Q is secant square x tan x into I of e raised to tan x and its integration with respect to x. We call this equation 2. Here it is product of three terms of x. Therefore, direct integration is not possible. We have to use the substitution. For tan x, put tan x as some t, new variable. Differentiating it with respect to x, we get secant square x dx is equals to dt. And therefore, substituting that value, we get a plus integration of tan x as t, secant square x dx as dt, and this becomes e raised to t. Therefore, that product of three terms is converted to a product of two terms. Then we can easily apply integration by generalized part. T is algebraic term and e raised to t is exponential term. Therefore, this is the first term and this is second term. We get first term t, integration of second, integration of e raised to t is e raised to t, then minus, derivative of t with respect to t is 1, terms alternately positive negative, and next integration of e raised to t is e raised to t. Next derivative 0, we stop here. From this two term I can take e raised to t common, and therefore it is a plus e raised to t, remaining terms are t minus 1, and then finally substitute the value of t. Therefore we get that required solution as here left hand side is y e raised to tan x is equal to a plus e raised to t, t is tan x, multiplied by tan x minus 1 as the required solution. Then once again the scheme of marking. For getting that linear equation in y, this step, all these steps, you will get 1 mark. Then for getting integrating factor, second mark. And this 1, 2, 3 steps, remaining 2 marks. Total 4 marks. Next example number 4. Solve dy by dx is equal to y plus 1 divided by y plus 2 into e raised to y minus x. Cross multiplying it, we get y plus 1 into dx is equal to y plus 2 e raised to y minus x into dy. Then transferring to left hand side, we get y plus 1 into dx minus y plus 2 into e raised to y minus x into dy equal to 0. We call this equation 1. It is written in the form of mdx plus dy equals to 0. Therefore, if we check it for exact, the coefficient of dx is m, y plus 1, and n is minus. If or we multiply by minus inside, we get the first term as x, then minus y plus 2 into e raised to y. Then differentiating m with respect to y partially, we get derivative as 1, and differentiating n with respect to x, keeping y constant. Therefore derivative of x with respect to x is 1 and derivative of this constant term is 0. And if you observe this term as dou m by dou y is equals to dou n by dou x equation is exact. For this step you will get 1 mark. That's showing that equation exact. Then next step होता है, next step is integration of m with respect to x, integration of m, here m is y plus 1, and its integration with respect to x. With respect to x, these two terms are constant term, we take outside, and integration of dx is x, we call this equation 2. Then next terms in n free from x, integrate with respect to y. Is there any term which is free from x? Yes, here is one term, therefore that term is minus y plus 2 into e raised to y, which we have to integrate with respect to y. Again a product of two terms, therefore by generalized part minus sign outside. Y plus 2 is algebraic and e raised to y is exponential. Therefore y plus 2 first term, integration of e raised to y is e raised to y, then minus derivative of this term with respect to y is 1, and next integration of it is e raised to y. A constant term, next derivative 0, here we stop. From this two term I can take e raised to y common. Therefore remaining terms are y plus 2 and minus 1. We get minus e raised to y, 2 minus 1 we get 1 as third. And then solution is sum of these two and equate it to c, and therefore solution is x into y plus 1 minus e raised to y, y plus 1 is equals to constant c as a required solution. For this step, next 1 mark. For integration of this with respect to y, another 1 mark, and the last 1 mark for the final answer. Therefore total 4 marks. Example number 5th, 1 plus y square plus x minus e raised to tan inverse of y into dy by dx is equal to 0. Here the type is not mentioned. We have to identify its type and then apply corresponding technique. Dependent variable y, independent x, if we keep as it is, then cross multiplying it we get 1 plus y square into dx. Therefore m is 1 plus y square. Its differentiation with respect to y is 2y, and its differentiation with respect to x is 1. These two are not equal, means it is not exact. Then we think whether it is linear in y. We have two terms, y square and e raised to tan inverse of y. Due to this two term, non-linear term, it is not linear in y. Then we think whether it is linear in x. Only one term of x whose degree is 1, therefore it may be in linear in x. Therefore we try to rewrite in the form of dx by dy plus px is equals to q by rewriting it. Therefore cross multiply we get one plus y square into dx by dy plus x minus e raised to tan inverse of y equal to 0. Then keeping the term of x on left hand side and transferring the term of y to right hand side. We get 1 plus y square dx by dy plus x is equal to e raised to tan inverse of y. Then x is dependent, degree of that x is 1, degree of its coefficient, differential coefficient is also 1 and not multiplied together, means it is linear. Only we have to make the coefficient as 1. For that, dividing by 1 plus y square throughout, we get next step dx by dy plus 1 upon 1 plus y square into x is equal to e raised to tan inverse of y whole divided by 1 plus y square. We call this equation 1. Comparing, first of all, right, it is linear in x. And then comparing with general form, we get the value of p, which is the coefficient of x. Here the coefficient of x is 1 upon 1 plus y square. Q, right hand side term, it is e raised to tan inverse of y divided by 1 plus y square. P and Q are either a function of y or constant. Here both are functions of y. Then we find integrating factor as the next step. E raised to integration of p with respect to y, integration of 1 upon 1 plus y square, and its integration with respect to y. Integration is tan inverse of y. For this step, showing that it is linear, converting in this way, you will get 1 mark. Getting the value of if, another 1 mark. And remaining 2 marks for the remaining steps, means finding the solution. And therefore, solution is a dependent variable. Here the dependent variable is x into if. If is e raised to tan inverse of y, constant, plus integration of q into if, e raised to tan inverse of y divided by 1 plus y square into if, e raised to tan inverse of y and dy. Same base, therefore we can add the power, and I can rewrite this as a plus integration of e raised to tan inverse y plus tan inverse y. It is 2 times tan inverse of y whole divided by 1 plus y square, its integration with respect to y. We call this equation 2. To obtain the value of this integration, we take the help of substitution. Put tan inverse of y as t, differentiating it with respect to t, we get 1 upon 1 plus y square dy is equals to dt. Substituting that in equation 2, that equation 2 becomes, left hand side is x e raised to tan inverse of y a plus tan inverse of y is t, therefore it is e raised to 2t, and 1 upon 1 plus y square dy is dt. Its integration is e raised to 2t divided by 2, and then substituting the value of t, we get a plus e raised to 2 times t is tan inverse of y divided by 2. The final solution is x into e raised to tan inverse of y is equal to a plus e raised to 2 times tan inverse of y whole divided by 2. For this step, 1 mark, and last 1 mark for this, total 4 marks. In this video, I have discussed 5 different examples from that second unit differential equation. The most important step is to identify the type of that differential equation, because nowhere it is mentioned its type, whether it is exact, whether it is linear in y or linear in x, or whether it is reducible to linear. And after identifying it, we have to apply corresponding procedure to obtain the solution. In my next part, I will discuss some problems from the application of differential equation, either to electrical circuit or to mechanics. If you like my video, please share it, as well as subscribe to my channel, and to receive the notification for my such type of new videos, press the bell icon. Thank you. Thanks for watching.